Manage the blade to the sugar. This is like
last time we started the virtual lab, let's just finish the back. So we did a strong acid, we titrated a strong acid with a strong base. Okay, today we are going to do the back, which is a weak acid with a strong base. So I click on weak acid, and then I will choose I'm still going to fill out the burette with a strong base with potassium hydroxide. As a weak acid, this time I'm going to choose acetic acid, CH3COOH, which is the same thing as HC2H3O2. Alright? So I choose my weak acid, and I will choose potassium hydroxide as my strong base and fill the burette with the strong base. I need for you to pause the video right now and write a balanced chemical equation between that weak acid and that strong base. Write a balanced chemical equation between the weak acid and the strong base. Okay, before we add anything. You can pause the video to do that. I will not stop right now. Now, I need for you again to write down the molarity and the volume of the weak acid from the beaker. The molarity is 0.1495 molar of your acetic acid. The volume of is 25 ml. So you need to find the number of moles of the weak acid in the beaker. Find the number of moles of the weak acid in the beaker. I also want you to find the number of moles of the base in the burette. Number of moles of the base in the burette that you will need to neutralize that acid. Okay, now I'm going to start the titration. I will go a little bit fast. Normally you should not go that fast. I'm going to put an indicator again. I put phenolphthalein. Okay, and then I will start my titration. Even if I add 10 ml right now, if I add 10 ml, it's still acidic because you did not add enough potassium hydroxide to neutralize all the acid. Okay, I will keep on adding the strong base, keep on titrating. Okay, so I see a change in color. Let me repeat, I went too fast. So I need for you to write the volume of the base that is needed to neutralize the acid in the beaker. So write down 20.5 ml. 20.5 ml. Okay, even if I click OK now, I need for you to find the concentration. Find the concentration of the base in the burette. Find the concentration. I'm just going to enter a number now that is not right. But you need to find the right number. I will put 0.2319. I said it is not right, so don't write that number. If I see it on your paper, I will know that it's not right. And then I'm going to click on graph to see what happened. You need to sketch that graph. Sketch that graph. The x-axis is the volume of base added. The y-axis will be the pH. y-axis is pH. Okay, so we start at a low pH. As you keep on adding base, the pH will increase, and then if you measure that straight line and go exactly halfway that straight line, it will be your equivalence point. Last time we said the equivalence point is the point where the number of moles of hydrogen ion from the acid equal the number of moles of hydroxide ion from the base. This is the equivalence point. The end point is the point where you have a change in color in the indicator. So if you use the right indicator, the end point will be the same as the equivalence point, because when you have that change in color, that's where the number of moles of hydrogen ion equal the number of moles of hydroxide ion. Now I'm going back to the flip chart, and if you want to pull out your calculator, we are going to do some practice. So this virtual lab is due next class. So I need for you to get your calculator. Let's solve some neutralization equation. It says how many moles of sulfuric acid. They ask me for moles sulfuric acid. Okay, moles sulfuric acid are required to neutralize. They give me 0.50 moles of sodium hydroxide. This is a neutralization. Neutralization means you have an acid plus a base yield a salt plus water. Okay, now whenever we have a neutralization equation, always start with a balanced chemical equation. We will write a balanced equation, and the chemicals involved here are sodium hydroxide and sulfuric acid. So I have H2SO4 plus my sodium hydroxide yield. This is not equilibrium. Okay, so this is not equilibrium. This is an acid. It will give hydrogen ion. My hydrogen ion will go with the hydroxide ion from the base to produce the water, plus the cation ion from the base will go with the anion from the acid to produce your salt. So the right formula for the salt is Na2SO4. Always start with a balanced chemical equation. To balance it, I need 2 sodium hydroxide for every 1 H2SO4. Let's see. How many water? 2 water. This is a balanced equation. And then they gave me the moles of sodium hydroxide. It is 0.50 moles sodium hydroxide. All you have to do is a mole to mole ratio from first semester. Okay, so we start with our given, which is 0.50 moles sodium hydroxide. Do a mole to mole ratio. I put moles sodium hydroxide here, and moles sulfuric acid they ask me for. And I use the coefficients from the balanced equation. For every 1 moles of sulfuric acid, I need 2 moles of sodium hydroxide. And the answer is, what is the answer? It is 0.25 moles H2SO4. So this is from first semester. Okay, so you just do a mole to mole ratio. Let's see if we have the answer. It is 0.25 moles of sulfuric acid. Next page. A 25 ml solution of H2SO4, they give me the volume, is completely neutralized by 18 ml of 1.0 molar NaOH. What is the concentration of the acid? They ask me for the concentration of the acid. So this is stoichiometry. It is really stoichiometry. always start with a balanced chemical equation. The balanced chemical equation is we have H2SO4, which is the same as the other one, plus your NaOH yield. Remember, the hydrogen from the acid will combine with the hydroxide from the base to give you your water. The cation from the base will go with the anion from the acid to give you your salt, Na2SO4. And then we balance. We have 2 water here, 2 NaOH. They gave me the volume and the molarity of the base, so I can find the moles of the base. So I start with 18 ml. Why don't we change it to liter? Let's change it to liter. This is what? 0.018 liter. This is your NaOH. If we use conversion factor, this is 1 molar. 1.0 moles per liter, which is molar, same thing. 1.0 moles per liter. This will give you the moles. Liter NaOH, liter NaOH cancel out. We end up with 0.018 moles. 0.018 moles NaOH. And then we do a mole to mole ratio, 0.018 moles NaOH. Use conversion factor. This is moles NaOH to moles H2SO4. I use coefficient from the balance equation. So it is 1 mole of H2SO4 for every 2 moles of NaOH. And the answer is 0.009 moles of H2SO4. But we are not done. They ask for what? Concentration, molarity. So you need to take that moles and divide it by the liter. The liter is what? 0.025 liter of your H2SO4. And the answer is, okay, 0.36 molar H2SO4. So we have stoichiometry, means weight acid and bases. Okay, when a neutralization takes place, one of the product is always what? It is a salt. In a titration, if we have 45.0 ml of KOH is neutralized with 0.75. This is the exact same thing I just did, so I'm not going to do it now. All you have to do is you write a balanced chemical equation always. You find the moles of your acid. You do a mole to mole ratio. You divide it by the liter of the other one to find the molarity. So I'm not going to do this one. How many moles of HCl are required to neutralize an aqueous solution of 2 molar CaOH2? Same thing. You have to start with a balanced chemical equation. I'm going to switch to another flip chart to review few things from last class. Okay? H2S is considered to be weak acid because of what? Why do we say H2S is a weak acid? Because it ionizes slightly. Okay, calculate hydroxide ion. CaOH2, calcium hydroxide CaOH2 is a strong base because, now let me tell you, the stronger the Ka, the larger the Ka, the stronger is the acid. This is why I went back to that flip chart to review few things with you. Let me repeat. The larger the Ka, the stronger is the acid. The larger the Kb, the stronger is the base, because K is product over reactant. Okay, the larger the Ka, the stronger is the acid. Okay, another formula I need for you to write. Write down Ka times Kb equal Kw. You remember Kw? What is Kw? Equal what? 1.0 times 10 to the negative 14 at 25 degrees Celsius. Okay, so Ka times Kb equal Kw. One more formula for you. One more before my time is up. I need for you to write percent dissociation equal percent dissociation of an acid equal okay, it is the amount ionized, it would be your H plus, over the initial concentration of the acid. I will call it HA time 100 because it is percent. I will repeat specially for pre-AP. Okay, it is on your test. Percent dissociation equal the concentration of your hydrogen ion, that means the amount that is ionized, over the initial concentration of the acid, that's mean before any dissociation. Time 100 will give you percent dissociation. Okay? So, calcium hydroxide CaOH2 is a strong base. What is the answer? It is A. It has a large Kb. Large Kb. The Ka of three acids, the Ka is given below. Put the acids in order from the strongest acid to the weakest. Which one will be the strongest? The strongest is, I heard someone say 1. How about the second one? It will be 3 and then 2. It is 1, 3, 2. 1, 3, 2. One more. The Kb of 4 bases is given below. Put the bases in order from strongest base to the weakest base. Which one will be the strongest? Are you sure? It is? It is 4. And then the one after that? It is 3. And then? It is 1. And then 2. This is the order from strongest to weakest. So I